In this video we will show you how to work with the Verti Articulator. The Verti Articulator is ideal for attaching on to dental models for 3D printing. The design is low on resin consumption, and the models are designed to snap together after printing. You will find the Verti Articulator menu tabs just below the pin and the hinge articulator tabs. To import the Verti Articulator, simply press the button on the menu. The Verti Articulator consists of an upper and a lower base. In the posterior section is a hinge mechanism. The standard Verti Articulator is included in the Model Designer module, as can be seen here. However, different bases and hinges with unique designs can be purchased through the online store. Since it is possible to mix and match different bases with different hinges, the Verti Articulator is a useful addition to the Components module, where parts can be easily imported through thumbnail images. Before we begin, make sure your dental models are correctly aligned in the center of the 3D working environment. You may have used the articulator mounting table, which is also in order. Currently the bases are detached from the hinges, which allow the bases to be swapped with other bases with different designs. Since dental models differ in size, it is important that the bases can be scaled outwards and that they can be easily raised. In order to modify the Verti Articulator, first join the base onto the hinge mechanism. To do this, select the upper base first, then select the upper hinge arm in a double selection sequence. It is important you follow the selection sequence. The tool tips below will guide you through the process. From here, go back to the menu and press the hook base to hinge button. You can now move the base into an upwards or into a sidewards direction. You can also scale the base by using the S key. In order to achieve a symmetrical appearance, you can scale both bases at the same time. To do this, select the lower base, then shift and left click the lower arm in a double selection sequence, followed by pressing the hook base to hinge button. You can now select and scale both bases at the same time. With this we will conclude the tutorial. Thank you for watching this video. In this tutorial you will learn how to place the hinge articulator. We will demonstrate the procedure by using a hollow dental model, with individual dies. This requires an additional step, since the arms of the articulator will have to be shortened so that they don't interfere with the dies. To begin, navigate to the menu and find the articulation section. Press on the Hinge Type tab. This will immediately import the articulator into the scene. You can use the arrows to relocate the articulator along the X, Y, and Z axis. We will use the tilde key to position the articulator. The tilde key is frequently used in this video, as it sets the models into the correct plane. First, view the models from the top. Fine-tune the position slightly. When done, view the articulator from the side. Here you can adjust the vertical height. Make sure the articulator fits uniformly between both dental models. Always ensure that both the upper and the lower articulator components remain joined together. They should both have the orange outline when moving the articulator around. You cannot move one component of the articulator on its own, since the location of the hinge mechanism will be lost. Here you will notice that the articulator is slightly larger than the dental models. Our goal is to set the arms of the articulator so that they are in line with the base of the models. These have to sit flat down so that they can be in contact with the build plate when printing the models horizontally. Please remember, you cannot scale the articulator in size. Scaling the articulator will affect the offset spacer within the hinge mechanism. This will result in the hinge not being able to swivel after the models are printed. We will cover two possible scenarios. The first one is where the articulator appears too large for the models. In this case, the model bases will need to be extruded in length to match the arms of the articulator. The other would cover the reverse. The articulator appears too short. In this case, the arms of the articulator will need to be matched up with the models. In order to lengthen the upper base, you will need to select all the dies as well. Left-click the model to select it, shift left-click on the first die, shift left-click on the second die, and finally shift left-click on the remaining die. Use the tilde key to view the work from the side. Navigate to the upper Blender toolbar and choose the X-ray option. This will turn the selections transparent. An alternative way to access the transparent mode can be found in the Study Model section, the X-ray checkbox over here. Move back to the upper model and press Tab to enter into Edit mode. The mesh should be displayed in a black wireframe, as you can see here. By pressing the letter B on your keyboard, you will be able to access a selection box. Use this and drag the mouse so you can include only the upper vertices of the dental model. Go to the arrow, and drag it upwards so it matches the height of the articulator. Press Tab to exit Edit mode, then uncheck the X-ray box. We will repeat the process for the lower model. This follows the same sequence, so we will fast forward this section. As you can see, the arms of the articulator are now in line with the base of the dental model. This means that both components can sit flat down on the build plate. Next, we will cover the second scenario, where the articulator appears too small for the dental models. In order to do this demonstration, we will first lengthen the lower model. We will fast forward this section. The arm of the articulator is now shorter than the model. While it can be printed this way, you will need to either drop the model below the build plate for printing, or use additional support on the articulator. Again, use the tilde key to view the model from the side. Select the lower articulator arm, navigate to the X-ray checkbox, and click on that. Tab into Edit mode. Left-click in the 3D viewport, and ensure that the mesh is displayed in black. Press the letter B on your keyboard to call up the selection box. Move the mouse, holding the left mouse button down, in order to include all the lowest vertices of the articulator arm. Use the vertical arrow to extrude the arm downwards until it is in line with the base. Tab out of Edit mode, then uncheck the X-ray box. The arm should be level with the base. In the next step, we will lengthen the arm of the articulator so that it can be submerged into the model base. Turn the model so you can see the upper component of the articulator. Select the component, navigate to the menu and press on Edit. You should immediately see the navigation arrows displayed. Go to the green arrow and slowly pull the arm towards the model. At this point, observe how the structure of the mesh runs uniformly with this section of the arm. By pressing S on your keyboard, followed by X, you can scale the arm in the X direction to broaden it. Even though the mesh is being manipulated into different directions, the integrity of the mesh remains unaltered. This way, you can easily insert the arm into the body of the dental base. At this stage, there is no need to worry about the articulator arm interfering with the dies. Here it is very important to consider the structure of the mesh. In order to demonstrate a possible problem, we will go back several steps by pressing Ctrl Z a few times. We will go back to where we began extruding the front section of the arm, as we did earlier on. We will go back to the Edit tab, and click on that. This is the part where we use the arrow to pull the arm towards the model. Here, it is absolutely essential that you do not select the front face of the arm. If this face is selected and scaled down, it will compromise the integrity of the mesh along the entire length of the arm. As you can see here, a mesh which looks like this consists of overlapping vertices and switched normals, which may lead to difficulties when slicing and later printing the model. So if this happens to you, just go back a few steps and repeat the process. We will go back again to where we left off originally. Extrude the arm by pulling the arrow towards the base. Expand the arm slightly, then move it into the base. At this stage, there is no need to worry about the arm intersecting with the removable dies, since we will deal with this later on. Next, we will move on to the lower model. Again, select the lower component of the articulator. Go to Edit. Use the arrow to pull the arm towards the model. Look out for the integrity of the mesh, and ensure it has a uniform structure. Expand the arm outwards, use S for scale, then X to scale it into the X direction. Press Edit to finalize the process. Use the tilde key to view your work from the top. Select the upper articulator arm. Make sure it is highlighted, then press Shift and right-click to place the cursor on it. Navigate to the menu and press on Lasso. Left-click on a starting point, and by holding down the mouse, trace a line along the inner wall of the base, something like this. Ensure the lasso incorporates the parts of the articulator arm, which you want to get rid of. Go back to the menu and press Keep Outside. This will cut away the entire unwanted section. The honeycomb hollow and the individual dies are now unobstructed by the articulator arm. Use the tilde key and flip the models so you can view them from the bottom. Repeat the process, select the model, shift and right-click to place the cursor. Go to the menu and select the lasso cutting tool. Draw the lasso outline so that you can incorporate the unwanted areas, then press Keep Outside. With this, we will conclude the tutorial on placing the hinge articulator. Thank you for watching this video. In this tutorial you will learn how to stabilize your models using the articulation pins. Navigate to the menu and press the articulator button. You can move the pin structure by dragging the arrows in a desired direction. To fully understand how this component works, let's briefly explain how they are constructed. The pin consists of two parts. First, let's select and hide the upper component. Notice how the base has a slight conical shape. This form fits directly into its opposing counterpart. It is very important to keep these two parts together at all times. They cannot be separated from each other. If you move one part individually, the coordinates relative to the other part will be lost. Therefore, it is very important to always move or scale them together. To navigate through the scene as easily as possible, use the navigation widget, press the tilde key. Look at the objects from above. Navigate to the top toolbar and go into wireframe mode. In wireframe mode, you get a better indication of the positioning of the objects. Make sure both parts are selected. Both parts should be highlighted at the same time. Press the R key on your keyboard to rotate the pin. Use the G key to move the pin. You can now drag the pin closer to the area where you want to place it. Make sure the main cylinder does not enter the model, only the arm of the pin needs to be inserted into the mesh of the model. You can now copy the articulation pin by pressing the copy button on the menu. A new pin has been imported into the scene. Again, use the R and G shortcut keys to place the new pin in a different location. In this way you can add multiple pins. When you are happy with the vertical placement, start adjusting the structures in a horizontal plane. To exit wireframe mode, click this icon again. Turn your models to a horizontal plane. You can also use the tilde key for this. In this view, notice how the articulation pins are too short. Make sure both parts are selected, then go to the left tool menu and click on the scale widget. Go to the Z arrow and then scale the structure in length. Following this, access the Move widget and then move the structure to an ideal location. Repeat this procedure for all three structures. Remember, always select both parts while editing. If you would like to use shortcut keys, you can do this too. First, change the selection mode back to the mouse pointer. To scale the pins into a vertical direction, use the S key, followed by the Z key. To move the pins vertically, use the G key followed by the Z key. It is also possible to extend only part of the pin, if the arm is too far away from the model. In this example, the top is already in contact with the upper jaw, but the bottom part is still standing away. To extend the lower arm, go to the menu and click on the directional arrows. You can of course also access the wrench icon. This will get you into the editing mode for this procedure. Now drag the arrow to extrude the arm into the lower model. To exit the edit mode, press the icon again. It is best to place the pins in line with the models so that they can sit directly on the build plate when printing. By following the procedure in the previous tutorial, you can also lengthen the bases of the pins or even the model bases. If you only want to rotate the lower part, select the part, and then use the R key followed by the Z key. You can now export your work. Before we end the tutorial, we will briefly demonstrate how to use the square cutting tool to level the upper and lower surface of the models. Select all parts in the scene, either do this manually, or you can press the A key on your keyboard. Here it is best to use the tilde navigation key to view the case from the front. Place the cursor on the model on a point closest to you. Next, navigate to the menu and press the square cutting tool button. Use the S key to scale the square, and the G key to position the cutting tool, to cut both upper and lower surfaces in one go. Here, only select the lower two vertices and drag the cutting line upwards. When you are satisfied with the location of the tool, press Keep Inside, followed by pressing the Accept button. This has leveled the upper and the lower surface. With this we will conclude the tutorial. Thanks for watching this video.